Hello everyone. In this video, we will be discussing about knuckle joint and a design procedure of knuckle joint. So what is knuckle joint? Two or more rods subjected to tensile and compressive forces are fastened together and their axes are not alignments but meet in a point. So a joint allows a small angular movement of one rod relative to other. It can be easily connected and disconnected. So the applications of the knuckle joints are elevator chains, valve rods, etc. And here we can able to see a simple assembling of knuckle joint. So we will be having something called octagonal end, will be, in other words, will be called as the fork end. And even we have second important component, that is nothing but I end, and again this I end is having an orthogonal end. So what is the meaning of this orthogonal end? Means both the rods which you are trying to connect together, that is the fork end and the I end, which have here a same like the diameter rod at its end, that is nothing but octagonal end. Now I want to insert this I want to connect this fork end with the I end with the help of this pin. And this pin, you can able to see this, the diameter of the pin is exactly the same of the diameter of the fork end connector point. And even the collar also is used. Again, why this collar is used mean for the supportive purpose. And after inserting this pin, again a taper pin will be used for the further rigidness. And here we can able to see what and all we need to remember while designing a quarter joint. You can able to see a fork and yeah, eye will be there, and the diameters of all those things is clearly discussed here. So the diameter both the sides, that is the orthogonal end, it's supposed to be d. And apart from that, we will be having the collar, so the diameter, and even the what is that, the collar diameter of both fork and eye we need to find out. The outer diameter of all those things we will be finding out, and we will see how to design the knuckle joint. We will discuss. So these joints are used for different types of connections. Example, tie rods, tension links in bridge structure. In this, one of the rod has an eye at the rod end. The other one is forked with eyes at both the legs. A pin, or we exactly call it as a knuckle pin, is inserted through the rod end eye and fork end eyes, and it is secured by a collar and a split pin. These joints are used for different types of connections. Example, tie rods, tension links in bridge structures. In this, one of the rods has an eye at the rod end and another one is forked with eye at both the legs. A knuckle pin is inserted through the rod end eye and fork end eyes and is secured by a collar and a split pin. Normally, empirical relations are available to find different dimensions of the joint, and they are safe from design point of view. The proportions are given in the sketch. So this is the design procedure, or else in other language we can call it as the failure of the knuckle joint. So step 1 is failure of the solid rod in tension. Since the rods are subject to direct tensile load, therefore tensile strength of the rod is equal to pi by 4 d square into tensile stress. So when I am equating this equation with the load applied capital P, which is nothing but capital P equal to pi by 4 into d square into tensile stress. And from this equation we can able to find out the diameter. And second step is failure of the knuckle pin in shear. Here we will be having a double shear, so therefore the cross section area of the pin under shearing will be 2 into pi by 4 dt square, and this can be equated with the shear, and it can be connected with the shear. So 2 into pi by 4 dt square into tau. So equating this to the load capital P acting on the rod, we will be having capital P equal to 2 into pi by 4 dt square into tau. So from this equation, the shear induced in the knuckle pin is obtained. If it is less than the permissible shear stress, then the pin is safe in the shear. And moving to the third step, that is failure of the single eye or rod end in the shearing. The single eye or the rod end may fail in shearing due to tensile load. We know that the area resisting shearing is equal to d1 minus d2 power t. So therefore the shearing strength of the single eye or rod end is equal to d2 minus d1 into tau. So equating this into the load, we will be having P equal to d2 minus d1 into t into tau. So from this equation, the outer diameter of the eye, that is d2, may be obtained. You can able to see the sketch what is d1 and d2, inner diameter and outer diameter. And step 4 is failure of the single eye or rod end in tension. The single eye or rod end may tear off due to the tensile load. We know that the area resisting tearing is equal to d2 minus d1t. tearing strength of single eye rod end equal to d2 minus d1 t into tensile stress. Equating this into capital P, finally we will be getting d2 minus d1 t into tensile stress, which is equal to P. So from this equation, the induced tensile stress may be checked. In case the induced tensile stress is more than the allowable working stress, then increase the diameter of the eye. Then step 5, failure of the single eye or rod end in crushing. So the single eye or pin may fail in crushing due to the tensile load. We know that area resisting crushing is equal to d1t. Crushing strength of single eye or rod end is equal to d1 into t into sigma c. Equating this to the load capital P, we will be having P equal to d1 into t into sigma c. So from this equation, the induced crushing stress sigma c for single eye or pin may be checked. In case the induced crushing stress is more than the allowable working stress, then increase the thickness of the single eye. And step 6, failure of the forked end in tension. The forked end or the double eye may fail in tension due to the tensile load. We know that the area resisting tearing is equal to d2 minus d1 into 2 into t1. The tearing strength of the forked end is equal to d2 minus d1 into 2t1 into tensile stress. Equating this into capital P. So from this equation, the induced tensile stress, that is sigma t, may be checked. And seventh step, failure of the fork end in shear. The fork end may fail in shearing due to the tensile load. We know that the area resisting shearing equal to d2 minus d1 into 2 into t1. And shearing strength of the fork end, if we include means, and even if you are equating to P means, the final equation will be getting P equal to d2 minus d1 into 2t1 into tau. So from this equation, the induced shear stress may be checked. In case the induced shear stress is more than the allowable working stress, then the thickness of the fork is increased. Step 8 is failure of the forked end in crushing. The forked end or the pin may fail in crushing due to the tensile load. We know that area resisting crushing equal to d1 into 2t1, and the crushing strength of the forked end is nothing but d1 into 2t1 into sigma c, and equating this into load P, so P equal to d1 into 2t1 into sigma c. So from this equation, the induced crushing stress may be checked. So here itself we will discuss of the applications of cotter and applications of knuckle. So the cotter applications include simple to design and manufacture, simple to assemble and dismantle, very high tightening force due to wedge action which prevents the loosening of parts in service, connection of the piston rod with the cross heads, joining of the tail rod with the piston rod of a wet air pump, foundation bolt, connecting two halves of flywheel, that is cotter and the dowel arrangement. And applications of the knuckle include simple to design and manufacture, fewer parts, less cost, more reliability, simple to assemble and dismantle, joints between the tie bars in a loop trusses, between the links of suspension bridge, involved mechanism of a reciprocating engine, fulcrum for the levers, joint between the links of a bicycle chain. You can able to see the applications of a cotter joint. I think these are very common application which you would have seen everywhere. These are the simple applications, and applications of the cotter joint also we can able to see mainly these sketches and all. You are very familiar with this, and in cars, the connections, the trains, the tractors, so everywhere we could have seen these things, and even in car tires, and even where the the shaft which is connected to the wheel to the steering, we can able to see that connection is also nothing but knuckle joint. Thank you.